So welcome again. It's my pleasure to welcome you on Slevarna's stage. I'm happy that you stayed with us for the next talk, and it's my pleasure to introduce next speaker and invite on stage Harry Halpin. Harry Halpin is the CEO of Inim Technologies, a startup creating an initiative mixednet with anonymous authentication credentials. Previously, he led research projects against surveillance like at INRIA, like Panoramics and W3C web cryptography standardization effort. He has also been the target of undercover cops across multiple countries, including the infamous Mark Kennedy. So, Harry, floor is yours. Thank you.
Okay, thanks for the intro. I hope the audio is okay. So this, I don't know how many people were here 2 years ago at the Liberate conference, but at that conference, we gave a brief demonstration and a lightning talk on mixed networking. And of course, this year I'm very happy to return to no better place to present the software than the Institute for Crypto Anarchy. Well, we're going to go over how we can use mixed networking plus anonymous authentication credentials to essentially help build the kinds of software that the sort of founders of crypto anarchy, everyone from Timothy May to David Chaum, were all sort of pushing for back in the 90s. And I think now more than ever, this kind of software is needed. So that's me, that's Twitter. Feel free to follow us for updates. But I'd like to first dedicate this talk to Timothy May. He died on December 15th last year. And he really, I think, inspired by basically inventing the term crypto anarchy and really having the vision everyone here. And it's very sad to see him go, but I think we build on the shoulders of giants, and we do honor to his memory by creating the kinds of software that he envisioned. And what he envisioned is actually quite clear. He said that we can actually communicate with each other in a totally anonymous fashion, and that this kind of technology, based on rerouting and public key encryption and zero-knowledge proofs, will have such a large effect that it will be similar to the effect of the invention of the printing press and alter the relationships of power throughout all society, including the elimination of a lot of the previous power structures, such as just as the printing press destroyed the printing guilds, the pre-printing medieval guilds, and reformulated society to give us eventually the nation state and industrial capitalism, that will enter a new kind of society based on cryptography that will alter the current state of nation-state, post-Westphalian nation-states and corporations. And there was a huge war to make this possible. This is myself and Amir Taki, kind of peeking over the back, with Phil Zimmerman. And I think people need to remember that there was, not only was there the Crypto Anarchist Manifesto, but there was literally a decade of essentially court cases and software creation really to get us to the point where we could even begin contemplating things like Bitcoin, which we take for granted today. So, I mean, Phil Zimmerman eventually tried to prove that code could be considered speech, and he was prosecuted by the FBI for the release of PGP on Usenet. Eventually, Bernstein, who also did Curve 25519 and much of modern cryptography, and is currently working on post-quantum crypto, took it all the way to court and basically got it ratified that code was indeed, at least in the United States, protected under free speech laws and not capable of being sort of taken down as a form of munitions export. And it's exactly, these kinds of court cases and this kind of code which prevented the nightmare world of the Clipper chip, where the government would have a backdoor mandated into every cryptographic technology, from happening, and led to the sort of innovation that we saw really on the early internet. But now, and this is what got me interested in in Bitcoin originally. When I first saw Bitcoin, I said, well, there's going to be this huge problem. No one is possibly going to do any kind of payment where it's completely transparent on a distributed ledger. Who is paying who? And then when I saw people in the Bitcoin space became interested in privacy, it became very clear that what we were going to see is a second generation of crypto war, where, and as we're seeing today with the guidelines from various international institutions, court cases happening every day, that we are in the middle of a new kind of essentially war on code. And what we need is new kinds of weapons. And these weapons will essentially be code. It's not just code as speech, but it's code as a weapon to accomplish our political and social and economic goals, ideally in a manner which does not cause, let's say, does not cause us to lose. And what we're seeing on a larger front is a transformation away from what Foucault called disciplinary societies. So this is take it one step back. These kinds of societies, the kinds of societies that were formed after the printing press, essentially, everyone was in a sort of little prison with distinct rules and distinct ways of being. And you go from one to the other. So you were shuttled from the family to the school, maybe to the army, to a factory, if you got sick, to a hospital, if you committed a crime, to the prison, and then you died. But what was predicted by Gilles Deleuze was that this kind of society would eventually lead to a new form of nebulous, what William Burroughs called control, where there was no distinct ending or beginning to control. There was no distinct ending or beginning to any sort of these little enclosures that we would find ourselves in our daily lives, but that in order to cope with this kind of society, we would also need new kinds of weapons. So it's not just the goals of crypto anarchy, but it's really, I think, we need new kinds of tools in order to fight back for human freedom in a society based increasingly on pervasive surveillance and control. And there's a lot of problems, and I'm going to just list them from a technical perspective. So the first problem is internet traffic is inherently observable. Just by its nature, when it was designed, not only was it designed to be unencrypted, but that patterns are essentially visible to anyone who's watching on, for example, your ISP or your internet exchange point. So even Tor, when you send packets into Tor, Tor bounces them through a Tor circuit with multiple hops, but effectively, anyone who's watching all the hops can still correlate the patterns of traffic coming into Tor with the patterns of traffic coming out of Tor. And this becomes exceptionally a terrible problem when you're doing cryptocurrency transactions, even anonymous cryptocurrency, including Zcash, Monero, Mimblewimble. They all have this problem that when they do the peer-to-peer sort of broadcast stage, that peer-to-peer broadcast is observable, and any enemy, and we know that Chainalysis does this sort of work, can watch that peer-to-peer broadcast and effectively harvest, exploit that metadata to de-anonymize things on chain. The original Zcash paper basically assumes it's an anonymous communication channel. We've seen interesting work from Monero trying to integrate I2P, Tor, people trying to integrate Tor with Grin. But push comes to shove, all of these technologies, if your enemy, say Chainalysis or the NSA, whichever one you prefer, can watch the entire peer-to-peer network traffic, which is not that hard given how essentially few people still use these technologies. They can de-anonymize your transactions regardless of what you do on chain. And this is a pervasive problem and affects apps with centralized servers such as Signal, but even when you decentralize the server into peer-to-peer nodes, this sort of traffic analysis is very hard to defeat. And it becomes even worse because essentially with technologies like Tor, we have further problems. So not only is the metadata exposed to the network, but if you wanted to create something that would help defeat this, such as Tor, there's no incentive structure. So while Tor has proven itself to be more and more useful, the number of people running Tor relays has essentially remained fairly stagnant, between 6,000 to 8,000 for the last few years. And worse, even with Tor, when you access a website, because if you're not using a Tor browser, you have cookies, you log in with Facebook Connect, you have these centralized web apps and identity providers, which even if you try to secure your network traffic and make that private, can de-anonymize you. So what we present is, which we call NIM, Greek for name, but really we're talking about anonymous and pseudonym, is what we consider like a 3-layer solution. The first is a mixed net, and the mixed net provides the sort of traffic level privacy. And we do mixed nets a bit differently than David Chaum, and I'll explain how in a second. It's not a classical Chaumian mixed net, although David Chaum is a genius and we appreciate his work. We decided to go for a different kind of design. We use anonymous authentication credentials, which is a very old technology, which people kind of forgotten about in the cryptocurrency space, in order to anonymize effectively how to link into the mixed net. And then lastly, of course, we have a sort of token-based system to reward people for participating in this mixed net. And so let's just go over what, so mixed nets were invented by David Chaum. They pre-existed Tor, and if any of you are running things like cypherpunk remailers, you may have ran Mixmaster, for example, by the late Lynn Sossaman. And this technology is incredibly impressive. It features better anonymity than Tor, but it has historically been a bit slow. So packets come in a classic Chaumian mix, they're held, and then they're permuted, mixed up, shuffled like a deck of cards, and sent to the next node. And you do this a few times, and you get resistant against even global passive adversaries such as the NSA. But the problem with this technique is that when you just shuffle packets, you send them forward like that, well, you have to wait for the packet. You might never know if your packets arrive. The system tends to be rather slow. And so while David Chaum has some great new work, which unfortunately he wasn't here to explain on how to speed that up with pre-computation, we chose a different kind of mixed net called a stop-and-go mixed net. And how this does is it keeps the multiple hops, but it does some other things. First thing, rather than waiting for the next bit of traffic to come in, it basically just holds it for a small, often randomized delay. And these small kind of millisecond delays with enough traffic basically help break the pattern in the packets. Now, of course, if there's only a few packets coming in your network, that doesn't help you. So what you have to do is you have to add cover traffic. You have to make fake traffic so it always looks like to the enemy you're sampling essentially traffic from the same distribution. So the connections between the mixed nodes always have some traffic coming through them that's indistinguishable from the traffic at a previous time period. And this technique also lets you be able to loop the traffic back, so you can send anonymous traffic through a mixed net and then loop it back, and then that's sort of like an acknowledgement that your packet got through. So if your packet doesn't get through as fast as you want, you can send a new packet. And if you send 2 through, you get essentially a replay, and you just drop the replayed traffic. And this is fairly straightforward to scale. You can just add more nodes. If you want more security, you add nodes. It's David Chaum there. You add more nodes on a vertical level, and if you want speed, you add more nodes on a horizontal level. So I think we should all congratulate David Chaum for inventing mixed nets. And I think if you use his wonderful system, you don't need our system. And we do support Elixir. I do think that for other kinds of more generic anonymous overlay traffic, a new kind of mixed net is needed, and this is why we built the NIM mixed net from what's called the Lupix design. And this is just a quick illustration of how it works. So you see, first thing, packets have to be wrapped up on the user's computer using what's called Sphinx. And Sphinx is just a packet format which makes everything the same size, and it lets you do kind of encryption, authenticate encryption hop by hop, and re-randomize at every hop, therefore breaking the links between any packet. So you can't, for example, change a byte and packet on one hop and look and find it on the other. Then you add in, of course, multiple hops. Typically, in our current network, we have 9, but you can add more, like I said, more vertically to give you more security, because you only need one honest mix in the network path for it to be secure and unable to be de-anonymized. And you can add them on the top in order to basically get more capacity. If there's not enough traffic through, you add dummy packets. Again, at each hop, the packets are held for a bit, and you can see the packets come in, and they pop right out, and they're essentially anonymized. That's red, and they go to whatever service you want them to go. And you can look in comparison to Tor, where the PAT traffic comes in, but it comes out after a few hops, which is fine for obscuring your geolocation, but that's really all it does. You still have the same pattern of traffic, although, of course, Tor is better than a VPN, where you basically just go to someone else's computer and hop right back out. So, we've done a lot of testing on this mixnet. We have a full simulator, and what's really cool about mixnets is that even though they have a kind of reputation for being slow, at this point we can speed them up to get milliseconds level delays, and we can basically sort of tune it for different use cases. So for example, if you want to send cryptocurrency through a mixnet, you might want to be really private, and you want to slow it down. But if you want to send like text messages, encrypted messages, like Signal kind of messages to a mixnet, you might want to speed it up. And then you can mix these kinds of distributions of traffic so that people sending Signal messages can provide cover traffic for people using the mixnet. And then, of course, the problem is, if you just open a mixnet, this is actually something Adam Back told me 2 years ago here. He said, well, the problem is, Adam Back's like, people just flood it with traffic. And so that's why Adam Back basically programmed Hashcash, the proof of work algorithm that we currently use in Bitcoin. And the reason was that people were essentially flooding his little mixnet. And he wanted to basically make sure that they couldn't just flood it for free. So we said, well, we would like something like that, but doesn't require proof of work. So we chose to look at the literature on anonymous authentication credentials. And we use a new kind of anonymous authentication credential based on what's called the coconut signature scheme, which is too much to go into right now, but I'll just go over what it provides, which it provides decentralization. So it's like a blind signature, but unlike ordinary blind signatures, you don't have a single issuing authority that you're dependent on. Of course, it's anonymous. It uses El-Gamal re-randomizable cryptography. And it's selective disclosure. So rather than like a full ZK snark or something which lets you compute any program, you're essentially doing a large vector commit on the credential. And you blind that, and then you can reveal selectively using specialized zero-knowledge proofs for private attributes, things that you may want to reveal, for example, to a service provider on the other end. This could be something as simple as, I would like to send this cryptocurrency transaction through. This is the denomination. This is the sender. This is the receiver. To, proof that I'm a resident of the Czech Republic, or more importantly, I'm a member of Parallel Polin, or whatever it is that you need to get the operation off the ground. For example, for a messenger, you might need to provide a list of contacts. And you can, by proof of long-term key ownership, you can do things like long-term pseudonyms. And so this is our kind of overly complex scheme, but I do think it basically is the only one that works. Everything over here is linkable, which is public. Everything here is in black is anonymous, unlinkable. You basically get some kind of credential. You can take it from any sort of blockchain. We would like to use Bitcoin, but we need a smart contract functionality, which isn't quite there yet in Bitcoin, but we hope to get it soon. Then you can embed whatever credential, whatever information you want on that credential, get it transformed into this kind of credential, which then says, yes, I'd like to access a privacy-enhanced service, send it through the mixnet. The mixnet does that timing and pattern breaking that we discussed earlier, and it ships out, and then you can see you can basically anonymously use whatever service provider you want, and the service provider then uses a little custom blockchain, not a cryptocurrency, because we only would like one cryptocurrency, ideally, not create other ones just kind of randomly here. And we just basically use that, we use what's called the NIM blockchain just to check to see if the credential's valid, and also to maintain operations kind of information, such as who's in the mixnet, what's the PKI of the mixnet, and this sort of information. And works really fast in a few milliseconds, so much faster than ZK snarks on Zcash. And Adam back I really owe him on this one, because he really helped inspire this concept where I was saying, well, Adam, if we were going to redo Bitcoin from the beginning, what could be done differently? He said, well, the problem with mining is it does help maintain the economy, and that's great, and it makes everything stable. But privacy historically is really expensive computationally, and we don't have any incentives to let people make computation more private. So he said, wouldn't it be great if there was some way we could use all this computational power and these incentive structures that Nakamoto has taught us through Bitcoin, and use that to basically fuel privacy-enhancing technologies? And so that's kind of what we've done, actually. We've basically have developed a sort of token scheme so that we can get consensus for who's in the mixnet at any given time, and we can make sure that the mixnet is evenly distributed. It's not all in a single jurisdiction. So one of the main problems that Tor has is that most Tor users are in the United States. They would like to use Silicon Valley services, which are also in the United States, and most Tor nodes are in Germany. So essentially, you're bouncing users from the US to Germany back to the United States. What we would like to do is we would like to actually make sure that the network is global and resistant to state repression. So that's why we would like to sort of reward, for example, even a more low-capacity node in some place like Hong Kong or Indonesia or Malaysia, more than a high-capacity node, which is, for example, in New York or Amsterdam. And then what we really want is we want something that's called like proof of mixing rather than mining. So we want these rewards to be fair. We want people who are handing over machines in a permissionless manner to form a mixnet to be rewarded for mixing this traffic, for basically getting these packets, holding them for a few seconds, and routing them to the next level. And so we call that mix mining. And then, we would need to basically do what Bitcoin does, because what Bitcoin does is successful. It's proof incentive systems work. And so basically, we would want to have some sort of ability to take transaction fees to help pay for the mixnet over time, and some sort of fixed reward schedule so that people who come in early get more rewards than people that come in late, because it's more risky to run a mixed node in the early days than it will be once there's tons of traffic coming through and lots of fees. And the incentive structures are pretty simple, right? So users would like to have privacy and anonymous access to services. Service providers would like to be paid, but I used to run a VPN provider. You don't want to hold your users' financial data. That's just a honeypot for law enforcement. So you would like to be paid, but ideally in a privacy-enhanced fashion and not holding user data. Mixed nodes, as I said earlier, unlike Tor, should be rewarded economically for doing this work, running the server, pushing out these packets. And validators should receive rewards for maintaining the blockchain, which keeps the operations of the credentials and this whole system together. And so you would need something like credentials effectively to ensure that fees are taken in a way that doesn't reveal the identity of the user. So this is the algorithm that we've thought of. This is the first time I've really talked about it. What we do is we do something kind of similar. A verifiable random function essentially is a signature, like a digital signature, but without a message. But we can we can collectively produce bytes and show that those bytes are indeed random. So in the beginning of, let's say, an epoch, a period of time in our mixed network, you basically run a verifiable random function. That verifiable random function is then produces a random path through the mixed network, because again, we want it to be fair, an unbiased random path, and we do a commitment of that to the blockchain. Once you've done this commitment also chooses randomly a user to send in through a kind of measurement traffic. This can be thought of as, I think my friend Leif Riggi put it, a secret shopper, someone who's, pretends to be a normal packet, but's actually there to decide if someone's actually shipping packets correctly or not. So because we use the Sphinx packet format, which is this nice, also used in the Lightning Network, this really nice anonymous packet format, the mixed nodes themselves can't distinguish user traffic from cover traffic from essentially measurement traffic. So they can't tell if they're being rewarded or not. They're just getting packets and shipping them. And then every time, one nice thing the Sphinx packet format has a little nonce, a little random number you only use once, and then you don't use it again, to basically tell if a packet is being replayed or not. But what you can do is you can basically, locally on your mix node, just do every time you get a new packet in, you have to unwrap it anyways to basically get the next hop, and you take that nonce, you do a commitment of that nonce to a Merkle tree. Then at the end of the epoch, the time period, the VRF that you originally committed to is revealed, and all the mixed nodes can say, yes, indeed, I did get that packet, I did route it correctly, and if they reveal that they got the measurement packet, and they can prove that they got it using that nonce commitment to the Merkle tree, then they get rewarded. And if you run enough of this measurement traffic, you can basically fairly statistically sample an entire large mixed network. This measurement traffic is basically just cover traffic for whatever other kind of thing you're sending through the network. And this basically lets us fairly reward nodes. And so we can reward mixed nodes via this sort of mix mining algorithm I put forward. And we want to reward these validators for staying online, so we kind of measure them as well. When you want to create an anonymous credential, you ask the validators. If you don't get one, then you can write it to the blockchain who you asked for, and they can prove that they either did give you one or not. And then service providers, when you go through, send traffic through the mixed node, they collect these credentials, and at the end of the epoch, they can say, yes, I got this credential. Now I can prove that I don't know who accessed my service, but my service had 5,000 users or 6,000 users or 6 users, and they can also be rewarded for provisioning privacy-enhanced services to these users. Users can pay for these services using Bitcoin or whatever other cryptocurrency they like, and they can just pay a small fee to go through the mixed network. And I think that's priceless. So this scheme was discussed very briefly with Julian Assange himself. Me and George Denises went to visit him right before his guest list was cut off. And we said, mixed nets are clearly the future, and blockchains are clearly the future, and we really need to sort of pivot away from these sort of government-funded, voluntary-based systems like Tor, and build a kind of anonymity system which is self-sustaining, self-funded, and uses incentive structures and crypto economics to become really resilient to attack. And, he agreed, but unfortunately, he's no longer with us. I would recommend people buy the coins and be in solidarity with him. Those Julian Assange solidarity coins outside, I think. And people should not forget his case. I think his case is a real litmus test if someone is actually a crypto anarchist or not. A lot of people don't support him for whatever reason, but I think anyone under repression who's done the work that he's done needs support, and we're hoping to create this sort of technology, again, in his honor and the honor of Timothy May and other people who have come before us. And then what we're trying to figure out, which we're still working on, is how much the fundamental kind of denomination of this system should be. I mean, it would be nice to use Bitcoin, but I'm not Julian Assange. I don't have tons of Bitcoin to sort of bootstrap a fixed supply to get the system working. So we said, well, we kind of want essentially the system to be something logical. So whatever the fundamental denomination should be, it should be basically use of the mixnet for about 1 day, whatever that's worth, which is probably, we hope, something fairly small because we want lots of users, so something around like 1 penny. And then, we can take these fees out and feed it back into the system so that, and even hold some fees out in order to feed the system when there's attacks and when there's a lack of users and when there's denial of service attacks, so that the mixed network is basically continually growing even with a fixed supply of rewards. And I just want to say that there's lots of neat applications for this system, and I'm just going to bring up one. So unfortunately, my kind of co-founder, George Denisis, was acquired by Facebook and went over to work on the Libra. We do believe he'll come back someday because no one in their right mind would work on the Libra for very long. But the Libra really is a big threat. And it will use the massive amount of personal data basically created by Facebook Connect that's harvested by Facebook and use that for massive KYC, AML will be the kind of legal reason, but we'll basically use this to attempt to identify every cryptocurrency transaction. So we think it's time to get this technology going because it really is do or die time. We either will have pseudonymous and anonymous key-based private transactions, and we need to basically make sure Bitcoin can support this, or Libra will take over the world. And we do think that this kind of technology is essentially the only, and I think last best bet we have against the Libra. But I think that the question we have is, how is it that we can build better anonymity on top of Bitcoin? Because that's actually what we would like to do with this system. And I think the solution is the Lightning Network. So one of the problems with the Lightning Network, so I don't know who here, I assume everyone here is familiar with the Lightning Network, but there's two big problems. One problem, which I'm not really quite sure how to solve, is to create these payment channels, you need to have this sort of hot wallet. And no one really likes keeping their hot wallet online all the time because someone might hack it. I mean, I definitely don't. But there's another problem, which is at least for public channels. I mean, there are private channels we don't know about, but for public channels, the list of channels is basically public, and anyone, this is a visualization of them, can basically monitor all of the open channels and all the paths through the Lightning Network. And that's dangerous. Actually, what we would like to do is we would like to use this mixed network to basically form a privacy-enhanced backbone to the Lightning Network. And that's actually really easy because the Lightning Network already uses the Sphinx packet format, which my former co-founder, George Denisis, invented for mixed networking. So it's really a simple matter of basically letting those channels have multiple hops through a mixed network, and you can anonymize who's got the open payment channel to whom, which I guess makes it a little bit harder, at least, to figure out whose hot wallet I should try to hack. And so we think that could be a really killer use case of this sort of anonymous credential mixed-net-based technology. This is the current team. Unfortunately, I'm the only one here, but do feel free to get in touch with anyone. I am very proud of Dave, who left Facebook Libra to work on this project. So I think that we do have, there's a lot of commitment from people. And there was a lot of technology, and I went through it very quickly, so I honestly don't expect that explanation to be very good. But if you want a better explanation, you can go to all these wonderful papers which we've been writing for the last few years. And you can look at, for example, Anya, who works with us, built the Lupix anonymity system, which is the kind of non-incentivized mixnet that we're using that does this stop and go and this mixing. The Coconut signature scheme George Denisis built, which is how we got anonymous credentials to be decentralized, and various proof of stake and anonymity work that I've been working on as well. So I'd just like to say that there is hope, right? We have these kinds of technologies which have been germinating since the early 90s, since the really dawn of the crypto-anarchist movement, and we just need to basically go full steam ahead and get them out there and working and connect them to the actual things that we value and care for and use on a daily basis, such as Bitcoin and the Lightning Network. And that and we're really in a race against time, against Facebook Libra, and if not Facebook Libra, the Chinese government's cryptocurrency, or the American government's cryptocurrency, or whatever other new sinister totalitarian kind of system of control is coming up next. But again, there's no need for hope, no need for fear, and as Gilles Deleuze put it, the only thing is to look for new weapons. And we're going to release all of the code and a description of everything on, of course, the 5th of November, because what better day to do so? And you can look at the current state of development, and you can download the mixnet and run it and some other parts of it, although it's not fully integrated yet, by going to our website there. So that's it. If there's any questions, I'd be happy to take them.
Okay, thank you for sharing with us. I see right hand, and I see here, I see there. Okay, we have a few questions.
Thank you very much for an enlightening talk. I wanted to ask you a bit more detail. Like, you really think that Libra is a threat? Like, the decentralized crypto could really kill Bitcoin? And if so, how? How would that look?
Yes, I think it's fairly straightforward. So, unfortunately, the problem is there's a lot of people out there who aren't politically aware. People will just, they already use Facebook, they'll use Facebook Messenger, they'll use WhatsApp. WhatsApp in particular covers, as Preston Byrne put it, a quarter or a third of the sentient human life on this planet. And they will use that for monetary transfers. And the problem with that is that we'll normalize the sort of process of total identification that Facebook will require through the Calibra wallet. And they've said they'll require this in order to use the Libra. And as more people, if their first experience of digital currency is essentially a kind of, personal data, giving all their personal data to Mark Zuckerberg and his other lizard human friends, then they'll become used to it. It'll become normalized. And the kind of freedom that we experience with Bitcoin of using pseudonymous keys will become a relic of the past. And then what will be worse will be what could happen is what Amir Taki said in a very good, I think it's called Code as a Weapon, a very good blog post on CoinDesk, where he said the danger that we face with Libra is that it could fragment cryptocurrency so that all of the legal uses of cryptocurrency, all the approved uses of cryptocurrency happen through the Libra, and everyone assumes that the only use for Bitcoin is things which are, black markets, financing terrorism, and then that gives the government's excuse to crack down even harder on Bitcoin than they're doing today. And I think that's really dangerous. And so we need to have both resilience and better privacy within Bitcoin, and all these great usability Bitcoin stuff that I'm not really working on. All those need to get out the door really fast. Next.
Hi, great talk, thank you. If I understand correctly, your intention was to build NIM on top of the Bitcoin network, but currently Bitcoin doesn't quite have the smart contract capabilities due to the limitations of the scripting language. So maybe you could touch on that a little bit more. When do you foresee that problem being resolved, and could it possibly be an insurmountable problem, and if so, then what?
No, I don't think it's insurmountable. In fact, things like Schnorr signatures are finally coming online. Taproot is very interesting. And I do think that although you'll see this on our current code base, although we don't have it working natively with Bitcoin, we do believe it will be capable within the short term. It really depends on how quickly the Bitcoin core developers and Blockstream, everyone can really push out exactly those two things I need is kind of the minimum. You really do need Schnorr signatures and Taproot. And I have a lot of respect for Peter, a lot of respect for all those people working on them. I hope it's out there before we launch, because it would be bad if it wasn't. If not, we'll just keep working with Lightning, but we can't get really the full functionality until Taproot and Schnorr, and ideally some other features are added to Bitcoin. And Simplicity, which is this kind of nice, verified smart contract language built for Bitcoin by Russell O'Connor from Blockstream. I reviewed it. It's very good. I really want to see that pushing it as well, because then we can really enable all sorts of very complex payment. Because you see that, if you have a mixed node and you have services, you do need to have the kind of fees taken out on top of Bitcoin fees, and it would be really nice to do that on a sort of smart contract on top of the Bitcoin blockchain. I do know those people are getting very close to finish, but also they said that last year. So I'm hoping this year or next year is the real year it gets done, 2020. Next.
Okay, we have 3 more questions here. 1, 2, 3, and let's start here.
Thanks, Harry. Can you share any ideas on how you can run a mixed node or a Tor node if you don't want to attract attention and get the police knocking on your door and so on?
Yeah, so it really depends on what jurisdiction you're in. So the United States is a horrible jurisdiction for many things. It's actually a good jurisdiction to run Tor nodes in and mixed nodes in, because there's been rulings that basically say, just as your internet service provider is not liable for you downloading porn, you are not liable if you're running a node, particularly if it's encrypted and all the traffic was indistinguishable, for just passing traffic from one node to another node. That's a lack of intermediary liability. It's a well-known principle in American law. Unfortunately, other countries, in particular Europe, and in particular Germany, sometimes don't see it that way. And that's why we had the really unfortunate thing where Moritz, who was working with us on mixed networking, but also Tor servers, .NET, running a lot of Tor exit nodes, had his house raided by the Bavarian police last year. So I really think you got to choose your jurisdiction really carefully. A lot of jurisdictions have larger problems than Tor exit nodes and entry nodes. The middle nodes can be pretty safe to run because no one really knows what's going in and out. It's really the exits, the entries that really get hammered, particularly the exit nodes. And I do think that a lot, this is a thesis from Amir, but Amir believes a lot of dark markets are being shut down right now. That's why you're not seeing too many new Silk Roads right now, is because all these correlation attacks funded by DARPA and Carnegie Mellon, et cetera, on the Tor network. That's probably true, in which case a mixed networking would provide better defense against these kinds of attacks. And, finally, I think, what the real reason to have an incentive structure on top of a mixed network is that there is no incentive structure to run a Tor node besides kind of feeling, part of a community, helping the world, helping fight for privacy. And I believe in all those things too, but I would really like for someone to pay my court bills when the police come. And I think one thing is that if you're running a mixed node, we would like our system, through Bitcoin fees or however we do it, to basically give you, it should be very lucrative to run an exit node or keep all the traffic inside the mixed network so that you can pay your fees if there's any legal problems. And I think that's really the long-term solution to that problem, at least before the collapse and destruction of the nation state. And then it won't be a problem anymore. So,
Yeah.
sorry.
I just want to extend this question, like what is the current status of the project? Like when do you expect that we can really like download the node, install it, and get at least like the same profit that the server housing cost?
Yeah, so we are currently working out the crypto economics to make sure that everyone can make a profit. But if you want to run a node without profit, you can do it today. Just go to the website, there's a link to the GitHub, and you can download the mixed node code there. It is all in Go. We would like to recode it in Rust in C++ to get things to be faster, but we thought for version 1, pushing it out quicker was better than getting it perfect. So you can download and run a node today, and we have some demos that, I think we even have some of it Dockerized. It's pretty easy to test. That being said, I wouldn't recommend using it, because there are 2 things that you would need to use it besides just financial reward, and that's you would need to know how long to hold the traffic before passing it onwards, and how much cover traffic to produce. And these are called parameters. These are enabled, you can basically look at your traffic and figure out those kinds of parameters. And that software we do have working, but we don't have it working dynamically, so it can dynamically reconfigure those parameters. So we're trying to get that working, ideally as soon as possible. I wouldn't recommend anyone use it for real anonymous stuff until we get that working. And I think there's one more.
Okay, thank you. Now we have, and I see you again. Don't worry, you will get it.
Oh, last thing. If you would like to run a mixed node, we are going to be beta testing. If you go to the web page, you go down to the bottom of the web page. It says sign up for to run a node. Just write your email in there. We'll send you an email. When you're ready. It does cost about $1,000 a month on average to run a Tor node, but I think in countries like Prague and stuff, it's going to be considerably cheaper, just a few hundred, maybe less.
So regarding the NIM token, how do you foresee like the initial distribution, and how would you like to control the price if you say like the token should be valued at something like 1 day worth of running a VPN?
Yeah, I mean, the wonderful thing about markets is you can't control the price, and a lot of the pricing would depend on how much Bitcoin and other transactions come through the system and how much whatever crazy stuff speculators do. So that's kind of what we're trying to work out now by basically running lots of simulations to understand how we can make sure there isn't like a Mojo Nation kind of deflationary death spiral, and how we can really get some of the tributes that we saw with Bitcoin, which is, to be honest, at this point, relative price stability and a little bit of resistance to trivial market manipulation. So I think those are kind of open questions. We will do our best to answer those, and that's why we're not launching the system today. So maybe one more question.
Hi. Are you planning an ICO for this NIM token?
Yeah, that was what everyone was discussing 2 years ago, and I think unfortunately those are kind of out of fashion right now. So we are trying to figure out how to do it. There will be an announcement on November 5th. We haven't determined yet. I think essentially the best thing to do would be to fund the beginning through some sort of, if we had a massively rich sponsor that would throw down, that would be great. Until then, we have to figure out some way to basically fairly gather the rewards up. And so, I wouldn't put any kind of distribution mechanism totally off limits right now. But if you are a giant Bitcoin whale, we would be more than happy to talk. So.
Okay, so we can do one more question. So anybody in the audience with a question? No. Okay, so no ICO, no question. Okay, thank you, Harry.
Thank you.
Thank you for delivering a talk and sharing with us. I would like to just have just a quick note. I don't know if you noticed, but outside, behind the food stage, there is a concept called Descent Track. I don't know if you have a moment to see the track or to visit the place. Definitely find the moment. Actually, that's our last project, and we are still looking for support and to people who would like to, for example, host this track on your event next year. So definitely go and check the track and think of how can you use it within the sharing the ideas and concept we are building together. Thank you.